I think that if the Earth was twice as big, the dinosaurs would still be alive.
Whoa. Let's get this assumption going. How does this work?
So the dinosaurs went extinct 66 million years ago at the end of the Cretaceous period. And there are a few theories as to how they went extinct. There aren't any conclusive theories, but there are two main theories that most people agree on. The first one is volcanic activity. Marcus actually mentioned it a little bit. Just basically there were a ton of volcanoes everywhere and shot ash up into the air and blocked out the sun. And there was like 10 years of no sun, and that killed everything. The second theory is that an asteroid...
Chuck Norris.
Yeah, Chuck Norris.
Norris killed all the dinosaurs with roundhouse kicks.
The second theory is that an asteroid hit the Earth, and it basically did the same thing as the volcanoes. It wasn't the impact that killed them. It hit a bunch of like dust and debris into the air, and they called it impact winter, and it lasted for like 10 years and killed everything. So I think the more accepted theory is the asteroid theory. They're both pretty close, but I'm going to go with the asteroid theory for my answer.
Yeah, that's pretty cool, and it makes a better movie.
It does, yeah.
So if you look at the asteroid, they think they found the asteroid that actually hit the Earth. It's called Chicxulub. I don't know if I'm pronouncing that correctly. It's spelled Chicxulub. Chicxulub.
Okay.
I'm not going to argue on that one.
I'm sure someone will write us in and tell us we are pronouncing it wrong, but it'll be in text form, so we won't be able to understand what they're saying either.
Yeah.
It's not Chicxulub, it's Chicxulub.
And they actually found the crater of this in Mexico, and they estimate that it is 6 miles in diameter. And just analyzing the crater, they dated it back to 66 million years ago, so they're pretty sure this is the one, if it did happen. So I want to see if the Earth is twice as big, would this asteroid have the same effect? Would it wipe out all the dinosaurs? So right now the Earth is 7,800 miles in diameter. And I found a fact about asteroids. For any asteroid that is 1.9 miles in diameter, it'll burn up in the lower atmosphere. And that's if it doesn't have a high composition of like iron or anything. They looked at the crater and they found like a bunch of materials in it. They didn't find iron. So I'm going to assume that it didn't have iron.
Pretty safe assumption. If they didn't find it, it's not there.
Yeah. So if I scale this proportionally, if I compare the 1.9 to the Earth now and Chicxulub to twice the amount of Earth, I want to see, would it still have the same effect? So looking at the atmosphere for the Earth now, they said the lower atmosphere. I think that includes like the mesosphere, the stratosphere, and the troposphere. Those are really the three main layers that would like affect it. And these three layers combined is 50 miles thick. So if the Earth was twice as big, the way that the atmosphere was formed was that there's a bunch of gases released from volcanoes, and there's just gases from the Earth's core. So if the Earth was twice as big, there would be more gas from the Earth's core. Specifically 8 times the amount of gas, because it would be 8 times the amount of volume. That means that we'd have 8 times the amount of atmosphere. So just looking at the amount of atmosphere, doing the math, the atmosphere would be 370 miles thick for the lower atmosphere. So just for those 3 layers.
Beefy.
So looking at the ratio, if I do a ratio of the volume of the 1.9 diameter asteroid to the thickness of the atmosphere, that is 0.07. So in my comparison to the double-sized Earth, if I get a ratio lower than the 0.07, then it'll just burn up in the atmosphere. Anything higher will not burn up in the atmosphere and it'll hit the Earth.
Tell me, are the dinosaurs saved?
So the ratio I get when I do the double the Earth is 0.3, which is higher.
Yeah, no, it's not so great.
Yeah, it's much higher. But there's some other factors to look at. So the thing that breaks up the asteroid in the atmosphere, there are 2 things mainly. There's air friction and there's air compression. So air friction just like hits the asteroid and it breaks it up. Air compression is the asteroid is moving so fast that it compresses the air at a speed that heats it up. And it can reach up to 3,000 degrees Fahrenheit. And that burns up the asteroid. So that those 2 factors combined contribute into breaking up and burning up the asteroid. Since the Earth is twice as big, it has twice the amount of gravity, which means the asteroid will be traveling twice the speed. And the air friction is dependent on the velocity. It's actually an exponential relation.
Oh, good. That's always a good one.
Yeah, so twice the speed is going to equal 4 times the friction. So that helps. For air compression, I tried to find an equation for air compression. It was very difficult. There's like...
All I got was results for air compressors, and now Amazon wants to sell me 35 of them.
Yeah.
I definitely had a few times this week, by the way, where I was trying to Google for things and like the terms I had to use were not helpful whatsoever for actually finding what I was looking for. It was definitely one of those weeks.
Yeah, I mean, I found like an entire paper by NASA on the subject.
That helps.
And it was not clear at all to me.
Oh, maybe not.
I did not understand it. So
I still get results for extermination products from when we did the 6 inches tall question, and I was talking about being an exterminator. So I did a lot of research on rats, and so now Google thinks I have a rat problem in my house.
yeah, so I couldn't find anything. So I kind of just assumed that it was a linear relationship. So twice the speed equals 2 times the effect. I don't know, it could be different than that, but that's what I went with. So these two factors, I added them up, and I made an adjustment factor of 6. So I divide my ratio by 6. My new ratio is 0.05, which is less than 0.07. So the asteroid would burn up in the atmosphere, and the dinosaurs never would have died.
Awesome.
So we're probably all dead, huh?
Yeah, so we probably wouldn't survive.
Right.
We survived. Did we survive the dinosaurs? I forget how many dinosaurs we actually encountered as cavemen.
None, I think.
I'm
I think
so bad at history.
I mean, I've seen the Ice Age movies.
See, the thing about getting this one wrong is that it's when I look it up, I'm going to be embarrassingly wrong. It's like the Tyrannosaurus Rex was 35 million years before the advent of the humans.
Yeah, I'm pretty sure there was no overlap. I don't think it was anywhere close.
Yeah, we had kind of dinos. Like we had mammoths, which are like kind of dinosaurs. Kindosaurs.
Kindosaurs.